Hello, in this section I will go over how to solve equations in non-rational form and check for extraneous solutions. So what is non-rational form? It just means something in a non-fraction, right? So an example of a non-rational form would be negative 3x minus 4 equals negative 2x plus 8. So your goal here is to solve for your unknown variable and check for the solution. Check if the solution actually works for. So basically you're checking for extraneous. It's a lot easier than it's a lot easier for solving non-rational versus rational. So here are the steps. Step one, simplify and collect like terms before you move things around. So basically you want to get all the variables and all the constant on one side. That's your goal. And then to solve for x. So please use order of operation if needed. Once the left and right side of the equation has been simplified, get all the constant on one side and all the variables on one side. Okay. Step three, be careful not to completely get rid of the variables. So a lot of students make the mistake of actually canceling out the letter, which you need at the very end. But removing the constant as much as possible is okay. So get rid of the constants, meaning the non-letters. Solve for unknown variable and check it in by plugging it into the original equation to check for extraneous solutions. So sounds exactly what it sounds like. So let's do an example one. So example one says solve for unknown variable and check for extraneous solution. So basically, I want you to solve for y. So this one is a simpler example. We have 8y plus 24 equals to 0. So first step is check. So this is the left side of the equation. This is the right side of the equation. So before we start moving things around, we got to check if we can simplify the left side or the right side. So on the right side, we have 0. There's nothing you can simplify. It's just 0. On the left side, we have 8y plus 24. Can we combine like terms? No, right? The reason why we cannot combine like terms is because this has a letter and this doesn't. So if it was 8y plus 24y, then yes, you can combine it. So we can't combine like terms. So the next step is get all the constant on one side and all the letters on one side. So the constants are 24 and 0. So let's get that all on one side. I think it's best to move it all to the right. So how do I move this 24 to the right? Keep in mind, I want it completely gone. I don't want it to be a 1. That's always the difficult part. You want it completely gone. So how do I get this 24 completely gone? I'm going to do the opposite of addition, subtraction. And I got to do it in both sides. Okay, so this cancels. Now on the left side, you're left with 8y equals to negative 24. Okay. We're almost there. I just have to I want to get y by itself. So I have to get rid of 8. Now, a lot of students make the mistake of actually subtracting 8y, or no, not subtracting 8y, subtracting 8. Now, you can't do that because this has a y, right? If you're going to subtract something, you're going to have to subtract the whole thing. You're going to have to subtract 8y. And the reason why that doesn't work is because what is 8y minus 8y? It becomes 0, meaning you don't have the letter anymore. And we need the letter, right? So that won't work. We just want to get rid of the 8. That's it. So because this is 8 times y, let's do the opposite of the multiplication, division. So you're going to divide both sides by 8. Okay. So this 8 and 8 actually becomes 1. And then you have 1 times y, which is really just y, right? The right side, negative 24 divided by 8 is negative 3. Now, just because you have an answer doesn't mean it always works. So you have to check it for extraneous. So you're going to plug in negative 3 into the original problem. And if the left side equals to the right, that means it works. So it's going to be 8, replace y with negative 3, plus 24. Does that equal 0? 8 times negative 3 is negative 24, plus 24. That's 0 equals to 0. That's definitely true. So this concludes that y equals negative 3. Okay, so that was an example. Not too bad. Okay, go ahead and absorb all that. And let's move on to the next example. Example 2 says solve for unknown variable and check for extraneous. So this is almost very similar to example 1. So first step is before we start moving things to the left, check if you can simplify the left side and the right side. So on the left side, we have 5y plus 1, and on the right side, we have 0, right? On the left side, can we combine 5y plus 1? No, right? Because this has a letter and this does not have one. And on the right side, you can't really do much with 0. Okay, so now that we can't simplify, we're going to have to move things around. So let's get all the constant on one side. So I'm going to move this 1. I'm going to move it to the right, and I want it completely gone. So if this is addition, the only way to get it completely gone is do the opposite, subtraction. And you do it on both sides. Okay, so this cancels, and now you're left with 5y equals to negative 1. Okay. Then what we have to do is solve for y. I have to be careful with this step. I have to get rid of this 5. I don't want to get rid of the y. So I'm not going to subtract 5. I can't do that. Instead, because this is multiplication, I'm going to do the opposite of multiplication, dividing. And I'm going to do it on both sides. So I get y equals negative 1/5. Okay, now we got to check it. Put it back into your original problem. So it's 5, replace y with negative 1/5. Plus 1, does that give you 0? 5 times negative 1/5 is negative 1. Plus 1 equals to 0. This is 0 equals to 0. This is true. That means this is the answer. Okay, yeah, that's that one. Let's move on to the next problem. Okay, the next problem says solve for a random variable and check for extraneous solution. This one's a slightly different from the other two. This time we have a left side and a right side. So first step is check if we can, before we start moving things around, can we collect like terms? So on the left side, we have 3x minus 3. On the right side, we have x plus 5. Can we combine like terms on the left side? No, right? This has a letter, this has a constant. Can we combine like terms on the right side? No, because this has a letter, this has a constant. They're not the same thing. So now what we're going to do is, because we can't combine like terms, we're going to have to move things around. Let's start getting the constant on one side and get all the variables on one side. So let's start with the constant, this negative 3. Let's move it to the right. Let's get all the constant to the right. So I'm going to add 3, add 3. So you get 3x. This cancels. And then on the right side, you're left with x plus 6 and 8. Okay. Now let's get the variables on one side. So the variables are 3x and 1x. Let's get it on all on one side. So I'm going to subtract 1x, subtract 1x, because I want this x, I want it completely gone. So that's why I'm subtracting. Okay, so we have 3x minus 1x, which is 2x. And then on the right, you're left with 8. And the last step, or you want to solve for x, so I have to get rid of this 2. I just want to get rid of the 2, not the x. So this is multiplication. So I'm going to do the opposite of multiplication, divide. And I get x equals to 4. Whoops. We got to check it before we box it. So let's plug in 4 into your original. So it's 3, wherever you see an x, replace it with 4. So it's 3 times 4 minus 3 equals to 4 plus 5. Okay, so 3 times 4 is 12, minus 3, and then 4 plus 5 is 9. And then 12 minus 3 is 9 as well. Left equals right, that's true. That means we can conclude that x equals 4. Okay, I am going to stop here because I don't want it to get too long. We'll move on with examples. There's a total of 8 examples, so we'll do the others examples in another video.